All right, welcome back. We're going to do part 2 of lesson 4, solving quadratic equations. The next one is if you cannot factor, or you're having a real difficult time trying to factor, then we're going to use the quadratic formula. And this should be familiar with you from grade 10. The quadratic formula looks like this. Here it is in all its beauty right there. So the first one I did for you, put in standard form. So basically, what does standard form mean? That just means one side is equal to 0. So this one is already done because I've got the one side equal to 0. So then the other side is going to be the a, b, and c. Mr. Wills, where's the a value? The a value is in front of the x squared term. There's nothing there, so of course a is going to be 1, b is going to be 6, and c is going to be negative 27. We put it in. What I like to do right away is I always do the discriminant first. So this part right here is called the discriminant. We'll learn about more in lesson 5. But this guy will actually become, if I put in my calculator, it'll become 144. If I square root 144, I get 12. There's my b value, negative b, of course, and then my denominator will just be 2 times 1, so it's 2. So I get a negative 6 plus or minus 12 over 2. I do two answers, one for plus and one for minus. And then here I get the two answers, 3 and negative 9. So there we go. All right, let's do a little more complicated example. So this one is not in standard form. So the first thing we're going to do is bring everything to one side. If I bring everything to one side, I can bring the 5x squared to this side. What do you get, Mr. Wills? Well, if you get that, you bring it to one side, and you get 0 equals 5x squared minus 8x. So once I get this, step 2 says determine a, b, and c. You don't have to show these steps, of course. Well, you need to show this one. You want to make sure that one side is equal to 0. But once I get this, you don't need to show a, b, and c. But there's a, b, and c pretty clearly laid out. Once I get my a, b, and c value, I then substitute into the quadratic formula. And again, I always attack this part underneath the square root sign first, the discriminant. And if you've got a nice two-line calculator, just punch that in exactly as written. When I put that in my calculator, I get this, boom. So I get 64 minus 60, which of course is just, this is just equal to 4. And of course the square root of 4 is 2. So I get 8 plus or minus 2 over 10. I'm going to have two answers. My first answer will look like this, x equals, and here we go, I'm going to have 8 minus 2 over 10, which means this is going to be, excuse the equal signs on the same line here, but it's going to be 6 over 10, which is really 3 over 5. So there's my first answer. My other answer will be plus, so here's we go, I'm going to have x is equal to 8 plus 2 over 10. So this will give me x, 10 over 10 is just 1. So my two solutions to this are, or my two x-intercepts, or my two roots are x equals 3 over 5 and x equals 1. All right. There is the next one. Let's finish it off with a little more complicated example. All right, so here we go. I've got a quadratic on the left side and a quadratic on the right side. The first thing I want to do here is let's write out, we get ready to expand. So if I get it ready to expand, I'm going to have really 2x plus 1 squared is 2x plus 1 times 2x plus 1. On the right side, I just FOILed. Again, first, outside, inside, last, so I get this. I'm going to continue by expanding the left side, so here we go. I FOILed this left side here. Again, I'm not going to spend time doing this. This is something you should be familiar with. Here I added my like terms, 5x plus 3x, which is 8x. So I've got this, and now what I'm going to do is I'm going to bring everything over to one side. So I'm going to take all of this, and I'm going to bring it over here. Mr. Wills, can I go to the other side? Absolutely, but I like having a positive a value. I mean, you can do it with a negative a value, but I like the positive a value. So bringing all this side over, what do I get with that? I'm going to have 4x squared minus x squared plus 4x minus 8x plus 1 minus 15 equals 0. And so I'm going to simplify that a little bit further. So I get this. So everything is on the left side, and then the other side is equal to 0, so I can see my a, my b, and my c value. All right, what do we do now, Mr. Wills? Good question. So now we put it in the quadratic formula. So here's the quadratic formula. Again, attack the discriminant first. So there's my discriminant. Put in your calculator. You should just get a nice value out. Don't spend time showing me how to calculate this. I don't care. But just put in your calculator again, or do it in your head if you can. So I get this. So this is where we kind of go different from grade 10. Grade 10 we would find the square root of 184 because it's not a perfect square. But we are going to get an exact value. So what I'm going to do is I'm going to take this guy here and I'm going to break it up in perfect squares. So 184 is broken up into 4 times 46. So again, I broke it up into perfect squares. 184 is 4 times 46. So this is new. This is from Unit 1. We're breaking up that that radical into a perfect square and a non-perfect square. So we're going to make it a mixed radical. And what do we have next? So we get this. So we get 4 plus or minus 2 root 46 over 6. Then we look at all of the coefficients, which are right here. They're all divisible by 2. So our final answer will be this. X is equal to 4 divided by 2 is 2. 2 divided by 2 is 1, so plus or minus. But we still have the root 46, so root 46 all over 3. And folks, this guy right here, that is my final answer. As I said in class, we're looking for more exact answers than decimal answers, and that would be it. We are done. So that's really the only new thing for grade 10.